Good afternoon, everyone, and welcome to the third of 5 lectures sponsored by Advocates for Balance at Chautauqua, whose mission is to achieve a balance of speakers in a mutually civil and respectful environment consistent with the historic mission of the Chautauqua Institution. Today's lecture will be recorded and can be found in a few days on the ABC website. abc@chq.com. If you have a question for John Droz, hit the chat button at the bottom of your screen and type in your question in the lower portion of the screen, which will pop up to your right. And do it sooner than later because we take questions in the order they're submitted. John Droz is an upstate New York native who is an independent physicist. He's a long-term environmental advocate who is very involved with the 3 E's: energy, environment, and education. He's put together an informal coalition of 10,000 individuals, and about 700 of them are PhDs or experts. A key element of his efforts is to get the public up to speed on those 3 E's I mentioned. And his website, wiseenergy.org, is an example of that commitment. To augment the website information, he sends out an energy and environmental newsletter every few weeks to keep people apprised of the latest developments. All the back issues are available on his website as well. A lot of John's time has been spent in defending his profession, which is science. Since science has been a gatekeeper from bad ideas, I didn't say of bad ideas, I said from bad ideas, science has been under attack by self-serving special interest parties, recently now more than ever. Basically, John's position is that, number one, science exists to give us answers to our technical problems. And two, and as such, our technical policies should be based on real science. But that is not what's actually happening. For example, our energy and environmental policies are written by special interest lobbyists, and any connection with real science is inadvertent. As a result, there should be no surprise that these policies don't always work out as advertised and have numerous negative unintended consequences. We are pleased today to have John Droz share some unique perspectives in his talk, Critically Thinking About Climate Change. Ladies and gentlemen, John Droz.
Thank you for the kind introduction. I want to thank ABC for their invitation for me to balance the Chautauqua Climate Talks, and particularly Paul Anthony, who made the arrangements for me to speak today. I really appreciate this opportunity. This is going to be like speed dating, so please take notes as we go along. Yes, and I'll try to answer any questions you have at the end. Everyone else's mic will be muted today, so if you have any questions, as Paul said, please post them on the chat board, and I'll address as many as time permits at the end. Okay, based on recently adjudicated verdicts by the Court of Public Opinion, I'm obligated to give you fair notice that what follows is politically incorrect. Paul, can you see me in the new slide and hear me okay?
Yes, we can. Perfectly good.
Okay, great. Thank you. You can sign off. Again, my topic today is critically thinking about climate change. One of the most important issues of our times is this subject. I like this quote from Mark Twain, who had a wealth of other good insights and witty sayings. This observation applies to climate change in spades. So I'm aware that I am taking on a near impossible task here, tackling a very complex, technical topic that has extraordinary implications to our lives, with an audience having a wide range of scientific expertise. Furthermore, we have to overcome an enormous amount of misinformation that has been widely propagated. And if that wasn't enough, this has to be done in less than 45 minutes. Churchill is another person I love to quote, as his humorous comments are almost always spot on, like this one. JFK has some fine quotes as well, and this one hits the bullseye. Quote, "The great enemy of truth is very often not the lie, deliberate, contrived, and dishonest, but the myth, persistent, persuasive, and unrealistic. Too often we hold fast to cliches. We subject all facts to a prefabricated set of interpretations. We enjoy the comfort of opinion without the discomfort of thought." Oh my goodness, that's great. I'm interested in improving communication, so today I'm going to talk about climate change from a perspective that, to my knowledge, has never been done anywhere else in the world. Some may say that I have unrealistic expectations considering the heterogeneous nature of this audience, but I'm an optimist and don't think so. We'll see. I'm going to tackle this challenge in 6 quickie parts. A minute or so about me, a brief overview of what science is, an explanation of a basic way of solving problems that I call 4S, an advanced way of solving problems that I call 4S plus critical thinking. Then we're going to apply critical thinking to climate change, and lastly, we'll wrap it up by some conclusions about climate change. So, who is the man behind the screen here? The super short story is that I'm a scientist, physicist, and not really a public speaker. So I'm a bit out of my element here, and I'm sure you'll cut me some slack. I'm an upstate New York native and still have a summer home in Branningham Lake in the Adirondacks. That's where I'm speaking to you from today. I received degrees in both physics and math from Boston College, and then a graduate degree in physics from Syracuse University. I worked for a few tech companies and then retired from a management job at General Electric in Utica at age 34. That's an interesting story too, but for another time. The condensed version of what has happened in the 40 years since is that I've decided to become a citizen advocate and to focus on what I call the 3 E's that Paul mentioned: energy, environment, and education. It may not be apparent, but these 3 items are very closely interrelated. My science background gives me a perspective on these issues that is relatively rare, so I've probably given over 100 free talks. By the way, just to be clear, no one has paid me a dime for any of this 40 years of work, just like I'm talking with you today, gratis. The downside of my providing these free services is that I've become targeted by lobbyists, NGOs, etc., whose apple cart I've upset. For example, here's a study done by the National Sierra Club about who they say is responsible for slowing down the implementation of renewable energy in the United States. After about 20 pages of malarkey, they conclude that the 2 major culprits in the United States are the Koch brothers and me. Wow. Well, the Koch brothers funded a lot of organizations while I provided information. My takeaway is that this proves that education is as important as handing out money. Here's another major report at this time in the Scientific American. The background about how this article came about is quite revealing, but again, I'm sorry you don't have time to go into this right away. Here's another example. This is a peer-reviewed study, peer-reviewed now, about me and some of my successful efforts in North Carolina. Again, the backstory here is quite fascinating. Lastly, I was honored to be included in this well-known painting really. It's supposed to be me on the right. So you're not going to see me today, but that's what it is supposed to be. Just to show how these sources can play fast and free with the truth, I've never smoked in my life, and I'm a beer drinker, and they show me with a mixed drink. Not true. So why let the truth spoil a good story? Okay, that's all I'm going to say about me. Now a few words about science. The starting point in many of my talks is a brief discussion about science. To begin with, understanding the words we use is very, very important. For example, I can tell you that one of the first things our opponents try to do is to corrupt the language. A good example is the phrase wind farm. There's no such thing, as the only thing being farmed is subsidies. I refuse to use that phrase and tell wind promoters that I'll say wind farm once they start calling nuclear facilities an atom farm. They walk away after hearing that. So do we really understand what this common word, science, actually means? I don't think so. There is a fascinating dichotomy going on here. The vast majority of citizens think well of science, as the survey showed, yet very few people can give a concise definition of what science actually is. That discrepancy is repeatedly taken advantage of by self-serving lobbyists. Many marketers claim that their product is, quote, science-based, unquote, even though it's not. These promoters are counting on the fact that 99% of the public has little idea what science actually is, so their false claims are unlikely to be seriously challenged. That this study come up with mostly false science claims every 10 minutes is really telling. So let's cut to the chase. What is science? Well, the clothes you're wearing, the food you ate today, your transportation vehicle, the building you're in, the lights in the ceiling, the computers we're using here, etc., all came from scientific discoveries. These are based on many generations of scientists using logic and deductive reasoning, carrying out observations and measurements, formulating and then testing hypotheses and theories. When asked to define science, most people think of theorems and equations, but that is not science. This observation is spot on. Quote, science is a way of thinking much more than it is a body of knowledge. Our species needs and deserves a citizenry with minds wide awake and with a basic understanding of how the world works, unquote. The term science comes from the Latin word scientia, which means knowledge. The question is, how do we obtain knowledge in technical areas? Over thousands of years, we have worked out a methodology for discovering the technical truths of our universe. That is what the field of science is all about. Science is a process. The understanding that science is a process is critically important for our evaluating claims that are supposedly based on science, like climate change. The question always is, did they follow the process? Today we are overwhelmed with charlatans making many fake news claims about what's scientific. Science without the proper process is not science. Call it whatever you want, political science, pseudoscience, junk science, astrology, etc. But it is not true science. As it says here and depicts, science is the enemy of con artists, scammers, lobbyists, and other self-serving promoters. Okay, so what is the science process? These are the four basic elements. When advocates propose some supposed technical solution, like wind energy, our response should be very simple. Show me where a genuine scientific assessment has been made of your claims. Using these four criteria, it will be very apparent whether you're dealing with science or snake oil. By the way, no such scientific assessment has ever been done that proves all the claims made by wind advocates. A good question is, who has the obligation for going through this process? The answer is that when a new hypothesis or a product is proposed as a potential solution to a technical problem, it's up to the promoters to provide the scientific assessment that proves its veracity. It's not the obligation of others to disprove the hypothesis or to provide a, quote, better one. One more important science explanation pertinent to our topic today is we often hear the phrase global warming theory. Is that accurate, or is that another lobbyist deception? Make a guess. In most things in life, we are instinctively interested in certainty. But can science give us certainty? This quote says it accurately. Science has its weaknesses, and it doesn't have a stranglehold on the truth. However, science has a way of approaching technical issues that is a closer approximation of the truth than any other method we have. Here's an interesting graphical representation of the steps taken in science as it tries to proceed to certainty. This is important to understand. Question for our topic today is, where do we stand in these steps regarding the climate change matter? I think any competent objective analysis would conclude that we are at a hypothesis level. So the term theory is deceptive. I think this quote is prophetic. We live in a society exquisitely dependent on science and technology in which hardly anyone knows anything about science and technology. This is a prescription for disaster. We might get away with it for a while, but sooner or later, this combustible mixture of ignorance and power is going to blow up in our faces, unquote. Okay, hopefully you now know enough about science that we can proceed further. Part 3. The next piece of the puzzle we need to have is knowledge about how we're going to go about solving problems in general. Everyone here has had to deal with thousands of problems. That's really what life's all about, which is really a series of one problem after the other. Whether we did it consciously or not, we all develop a methodology for dealing with our everyday problems. I'm going to simplify things here a bit and say that your problem-solving methodology will likely fall into one of these 3 general categories. Surprisingly, or maybe not, inaction when facing a problem is the most common strategy used by most people. Well, why is that so? Here are some explanations. You don't know what to do with the problem you're faced with. You believe the problem will go away by itself. You hope that someone else will take care of the issue. After reflection, you decide the problem is not a big deal. You think it's more trouble addressing than it's worth. You figure that there's nothing you can do about it. And of course, it may be you're just a procrastinator or lazy. So the next level up from inaction, I'm calling the basic 4S problem-solving approach. Here are the 4 S's of this strategy, problem-solving strategy: source, severity, solution, and substantiation. Let's do an example. Let's say you own a real estate business and it's not doing as well as you'd like it to. The basic problem-solving methodology here is that you would try to have an honest answer to each of the 4 S's. For example, you decide that the problem source is that there aren't enough sales. You then assess the severity as not being catastrophic, but moderate. After considering several options, you decide that the most appropriate solution is to provide better sales training to your agents. Finally, you look at the results to substantiate the appropriateness of your chosen solution. If results aren't good, then you try something else. That's a quick example of how a basic problem-solving approach works. Essentially, the more advanced problem-solving adds critical thinking to the basic 4S methodology that we just went through. What does critical thinking mean? It means that we analyze a problem more objectively, more broadly, and more deeply. Here's what we mean by each of those 3 terms. These are some of the opposites of critical thinking. And we see a lot of these on topics like climate change, wind energy, etc. By the way, confirmation bias means that we investigate something with our mind already made up and then just look for things that support our initial belief. That is not science. So the upgraded 4S problem-solving process with critical thinking still uses the basic same ingredients, but it does them more objectively, more broadly, and more deeply. Okay, now we've had a quick review of how to solve tougher problems. Let's apply this to climate change. Sorry, skipped ahead to this. Here's the climate change solution spelled out with the 4S methodology. The proponent's claims are climate change source is CO2. Climate change severity is extreme. Climate change solution is wind energy, etc. Lastly, they say they have proven results to substantiate all of this. So, if citizens, scientists, legislators, etc., want to determine the legitimacy of the climate change story, then the most effective way to really do it is to critically analyze all 4 of those elements. So all this preliminary talk we've had today here is leading up to what we're here to do. As the slide says, I wrote 3 special different reports, each one specifically addressing one of the first 3 problem-solving elements. Obviously, we don't have the time to go through all of each of them today, So I'm showing you two places where you can easily get these reports so that you can then carefully review them at your leisure. May not be immediately apparent, but I put a lot of effort into making these reports to be citizen friendly. In other words, they are short, logical, understandable, hopefully interesting, and scientifically sound. So here's the cover of the first report. This is what it looks like. The defense of CO2 investigates the claim that CO2 is the source of climate change. This report examines 15 different key assertions about CO2 made by climate change advocates. 15. The takeaway from this report is that every single one of these claims is shown to be suspect. Note, none of this is my opinion, as multiple scientific studies are cited for each of the 15 critiques. Altogether, over 200 studies cited. We don't have the time to go through all 15 today, so let's look at one simpler example. The United Nations Climate Change Agency, the IPCC, states that the residence time of CO2 in the atmosphere is over 100 years. By the way, I'm assuming you know what the IPCC is and the major role they play in the climate change matter. If you don't, then my second report, which you're going to come to in a minute, has much more information about the IPCC. Why is this matter important? Residence time basically means how long will newly generated CO2, for example, from fossil fuels, stay in the atmosphere before breaking apart or going in outer space, etc. If residence time of CO2 in the atmosphere is over 100 years, as the IPCC claims, that means, assuming that CO2 is actually bad, it's extremely urgent to stop putting CO2 in the atmosphere immediately, because all new CO2 we generate will stay in the atmosphere for a very long time. Let's compare what the IPCC says to what independent scientists have concluded about atmospheric CO2 residence time. Here's a graphic representation of what 36 peer-reviewed studies said about atmospheric CO2 residence time. Remember, every one of these peer-reviewed. Their average conclusion was that the residence time of CO2 in the atmosphere is less than 10 years. That's a profoundly different result from what the IPCC says. Here's a recent peer-reviewed study that concluded that the average CO2 residence time is about 4 years. So altogether, these 37 peer-reviewed studies are saying that the key alarmist claim about CO2 is likely false. If these scientists are right, it means that the new CO2 gets out of the atmosphere much more quickly than the alarmists at the IPCC are saying, which means that the climate change situation is much less dire than they say. So if you download this report from the links I showed you and go through all 15 rebuttals, I think you'll see that there is considerable evidence that indicates that CO2 is nowhere near the culprit that climate change alarmists are making it out to be. The result is I'm putting a big question mark about the source of climate change. Next, here's the cover of the second report. The 4 Pillars of Climate Change takes a deep dive look into the 4 sources of authority that are most commonly referenced to support climate change concerns. So if you ask people, why do you believe in climate change? They reference one of these 4 things. They are the IPCC, which we already mentioned, the supposed 97% consensus of scientists, 3 computer models, and 4 extreme weather events. Again, because we're time limited here, we're just going to look at one of these 4 pillars, computer modeling, and see how solid a support it really is. Slides I'm going to show you are part of a more detailed analysis I put together, which actually explains 8 different reasons why computer modeling for climate change is highly suspect. The link for that full computer model critique is in the second report. We need to give some critical thinking to this query. Are computer models appropriate or accurate for climate change? The answer for this boils down to answering 2 important different questions. How accurate are computer models for an extremely complex situation and for a long time in the future? I'm a believer in simplifying things. In this case, we can answer those two questions by looking at the accuracy of computer models for moderately complex short-term matters. In other words, as it says on the slide, if computer models for moderately complex short-term matters are reliably very accurate, then maybe we can extrapolate that success into creating computer models for more complex, longer-term matters. However, if they're not reliably very accurate, then it makes no sense to assume that more complex, longer-term matters can accurately be modeled. What we're going to do is look at hurricanes, as tracking hurricanes is an outstanding test of a computer's ability to accurately model a moderately complex, short-term scenario. It's a good test because, due to the major life and death consequences of accurately knowing a hurricane's path, a significant amount of time, effort, research, expertise, and money has been expended in creating accurate computer models for this situation. Also, due to the enormous impacts, these computer models are run on the most powerful computer hardware we have. And thirdly, this is a very short-term situation, so we'll know the accuracy of the model within a few days. We don't have to wait any 50 years. So let's look at a recent major U.S. hurricane and see how accurate computer models were for this moderately complex short-term scenario. Hurricane Matthew is used as an example. This was a rare, extremely strong Category 5 hurricane, so it was given a lot of attention. Here are some sample headlines about it. So here we go. This first picture is early in the process, where Matthew just got to hurricane status. The first thing to note is that they did not have enough confidence in any of their models, so they show 6 different models. Point 2 is that none of the 6 models agreed with each other. Point 3 is that 9 days in advance of making U.S. landfall, not one of these 6 models was accurate. No, the light green track is actually what happened. Now, let's look at what happened every subsequent 2 days, starting with 9. This is 2 days later, 7 days before U.S. landfall. Still, not one of these 6 powerful computer models was correct. This is 2 days further, now 5 days before U.S. landfall. Still, not one of these computer models was even remotely close. Not one. This snapshot is now 3 days before U.S. landfall. Amazingly, not one of these computer models was accurate. And just look at the diversity among them. Oh my goodness. Here we are 1 day in advance of official landfall, and for the first time, probably by accident, one model, the dark blue one, is now correct. Just think about it. 1 day before official landfall, and 5 out of the 6 models are wrong. Very wrong. Just look at the diversion that they're projecting here. They're not even close to being right. This snapshot is 2 additional days further on, 1 day after the United States landfall. Astoundingly, the one earlier correct model, dark blue, is now back to being wrong again. OMG. Oh my goodness. So to review, this is the full actual path taken by Hurricane Matthew. What I hope you understand from the evidence I showed you is not a single one of these 6 top computer models was even remotely accurate throughout the whole transition. Bottom line is, despite spending a significant amount of money, time, effort, research, expertise on modeling, and despite running these models on the most powerful computer hardware on the planet, the inescapable conclusion is that computer modeling is not a proven, reliable methodology for getting an accurate projection of even a moderately complex short-term scenario. We don't have to be Einstein to figure out that for a highly complex, long-term scenario like climate change, that the accuracy and reliability of models would be orders of magnitude less. As I mentioned earlier, the major fault I just explained is one of eight serious deficiencies in computer models. To see the other 7 problems, check out the link for my slideshow in the 4-pillar report. Here's an insightful Dilbert strip about computer models. Scott Adams has got some really good stuff about climate change. Here's another. So the bottom line about computer models is that we all have an innate interest in the future. Popularity of horoscopes to palm readers attest to this predisposition. Who doesn't want to know what will happen tomorrow? Who doesn't want to be prepared for problematic future situations? We all do. That said, there is no known gene or the human ability we have to be able to reliably forecast the future. None. We can make powerful machines, but they are restricted by human limitations. For example, every climate computer model is entirely dependent on humans accurately identifying all of the variables and then accurately specifying the role each of these variables plays, and then accurately identifying all the interrelationships of all these variables. Since there are enormous gaps of our understanding of climate change, all such computer models are no more reliable than consulting a fortune teller. What this means is that we do critical thinking about the second element of a problem-solving methodology, severity, which is based on computer models, that it comes up to be highly suspect. Okay, we're getting close to the end here. Here's the cover for the third report, Taking the Wind Out of Climate Change, which takes a hard look at one of the main solutions proposed by climate change advocates. For example, Joe Biden's recent outline of his climate change plan, if he gets elected, included a provision for at least 10,000 industrial wind turbines. This report does some critical thinking analysis about industrial wind energy. In fact, it examines wind from 5 unique perspectives. Some startling findings are that there are no scientific studies proving that wind saves a consequential amount of CO2. Second, there are scientific studies concluding that wind can make global warming worse. Third, there are scientific studies concluding that gas can save more CO2 than wind. This is all explained in that report. How many of these facts have you seen in the mainstream media? To examine the studies behind these findings, please read the third report. So our critical thinking examination that the solution part of the problem-solving methodology is also highly suspect. This brings us to our fourth and last element of the problem-solving strategy, substantiation. So how will climate change proponents rationalize it if the substantiation part of the problem-solving methodology undermines their entire case? The evidence I've shown you that all of the prior 3 items are suspect, so that it's almost certain that that is exactly what will happen. Well, the alarmists are acutely aware of how embarrassing that would be, so they've painstakingly avoided any meaningful substantiation. Take one of the leading alarmist states, New York. Even though New York repeatedly claims that the world's survival is in the balance, they are not doing any real substantiation. It's all based on faith and the claims of salespeople. For example, New York State does not accurately show the real CO2 consequences of industrial wind projects. They don't acknowledge that the gas is part of it, for instance. Also, New York State does not require industrial wind developers to prove how much CO2 they are actually saving. This is like 3-card Monte. Citizens think they know where the ball really is, but they actually have no idea whatsoever. The not surprising result from the fourth problem-solving element is there is no proven substantiation of their climate case. So we're now almost done. And this is the inner overview of how well the climate change story holds up under a critical thinking analysis when examining it with a proven problem-solving technique. In my view, these are 2 great insights that apply to the climate change story. So I've alerted you to 3 good reports, each one exposing the weaknesses of the first 3 parts of the problem-solving methodology when applied to climate change. There is no 4th report, as we can't discuss what doesn't exist. Substantiation of the first 3 parts. You can draw your own conclusions from our brief analysis today, but these are mine. Number 1, climate change proponents have not adhered to the 4 elements of the scientific process: objective, comprehensive, transparent, and empirical. Number 2, presently, climate change is a scientific hypothesis, not a theory. 3, what that means is that climate change is unequivocally not a scientifically resolved matter. 4, there is no imminent existential threat in the foreseeable future. 5, there are strong indications that this is not about climate, but about other undisclosed objectives like world governance. And lastly, false climate solutions like wind and solar are being foisted on us by self-serving parties with economic and political interests. Despite all these shortcomings, my personal belief is we should address what's called climate change by making common sense decisions. For example, we should support nuclear power. Put another way, we are witnessing an epic battle between science and political science. Whichever is the winner will have incomprehensible impact on our economy, our society, and our freedoms. Again, there's much more on my website, wiseenergy.org. Make sure to read the 3 reports that are all on the global warming page. If you email me, I'll sign you up for our free monthly energy and environmental newsletter, which currently has about over 10,000 subscribers worldwide. So that's it. Thank you for your patient attention and hearing my concerns as a scientist and a citizen. If nothing else, I hope this information has gotten you thinking. I'll now be glad to answer some questions that are listed in the chat box. I'll also be glad to answer any future questions you have if you send me an email.
Okay, John, do you want to check the questions that have come in, or do you want me to read them? Or what?
Sure, I'm doing that now.
Okay.
Okay, Peter Gill says he wants to see me. Thank you very much, Peter, but no, this isn't about me. This is about the slides. Blah, 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 blah.
The first question, John, is by Peter Gill again. It says, in the case of AGW, is it at a failing hypothesis level? I think you answered that, but.
Well, it's at the hypothesis. I don't know. I'm not saying it's failing. A hypothesis means it's a proposed matter. It's a proposed idea. In my view, it has not been adjudicated at this point here. So I'm not saying it's a false hypothesis, but I'm saying it is a hypothesis and it hasn't been adjudicated to being true or false. So there's a lot of good evidence that says it may be true, but there's also a lot of good evidence that says it may not. So anybody saying this is a resolved matter here is just not being accurate.
Do you want to read the next question, or do you want me to do it?
I'm agreeing now.
Okay.
Several years ago, I read a paper saying the explosion of climate change paper was directly due to and proportional to the government funding of such studies. Would you agree, disagree, or comment? Yes, I would agree to that. There's been several analyses of that matter. Scientists are, that's one of the driving things behind scientists. They need to get recognition. They need to have some funding. For instance, if they're in academia, particularly, they're expected to do certain things that bring in money, and the biggest source of money by far is the federal government. So there's no doubt that the federal government is a driver of this. Yes. A few years ago, NASA scientists predicted 30 years below normal temps because of reduced solar activity. Well, there's a lot of discussion about the impact of solar. It's pretty obvious that the sun is a major driver of our energy, temperatures, etc. That's one of the hypothesis matters here, that we haven't really gotten this resolved as to exactly which of the factors that we're dealing with here are the most influential. So I'd say that's an unresolved matter, but there's certainly good evidence that the solar sun's impact on us is a major player. Okay. I believe that CO2 is essential plant life. Well, yes, that's indisputable that it is. I didn't bring that up as an argument because I say we're looking at other things here, but there's no doubt that CO2 has some benefits. But even if we acknowledge it has some benefits, that doesn't mean that it could also have some harm. So that's why I didn't point that out, because just proving benefits doesn't necessarily eliminate possible harms. So the 15 claims that are made by the proponents here are all harms that are in my first report here, and we discuss the harms part of it, whether they are legitimate harms or so forth. Okay. Okay, some other good comments here, not necessarily applicable to what we're talking about here, but yes, they're related here. Okay. Advanced nuclear is the only future that will work over the long time. That's likely to be true, but there are other things that we have optimism about. For instance, geothermal. There was a study done by MIT several years ago saying that comparing geothermal, this is deep geothermal. We're talking about going thousands of feet down now, not 10 feet or 20 feet, industrial geothermal. That these have been, that this MIT study concluded that it was, number one, economic compared to other sources, and number two, this would be accessible to something like over 90% of the planet. In other words, you didn't have to be in some particular unique spot to be able to drill down. And a lot of this was made available by some of the techniques that have been developed in our oil drilling business, where they can do really amazing things. You know, they can drill straight down for, I don't know, 2 miles and then do a right-hand turn for another mile, stuff like that. Pretty sophisticated thing. So I hold great promise for geothermal, because as the closer we go to the center of the earth here, we have effectively unlimited amount of heat below us. So that's something else that at some point we will hopefully tap into, because there'd be very little, if any, downsides to that. We can get it to work efficiently and so forth. Okay. Talk about the dominating role of water vapor. Well, that is a good point. When we talk about what are the drivers here, the proponents usually disregard climate change, because I'm sorry, slip of tongue. Disregard water vapor is what I meant to say, and they focus on carbon dioxide, which the water vapor part is actually about 100 times, if not more than the CO2 part. So things like clouds and other things like that are some of the things that, unfortunately, they just seem to, I don't know, cavalierly is the word I guess I'm looking for, dismiss as being not an influence. But I personally think that that's not proven. That's part of their hypothesis that needs to be proven here. So water vapor is a major player. Are any policymakers receiving this information? Well, some. Unfortunately, our policymakers, by and large, are inundated with paid lobbyists. So it's hard to get their attention, because every day they're being, I mean, literally every day, they have lobbyists waiting to see them and their staff. So when they get 100 things from a lobbyist and one thing from somebody else who's not a lobbyist, it tends to get lost, unfortunately. So that's part of our challenge here. Okay, it says, don't you think we should do everything to limit carbon emissions today, including a carbon tax? Well, no, I don't think that. I think this is sort of what's happened with the COVID matter here, that there's been too much focusing on one side of the issue. All these things are two-sided issues. So the carbon tax has been well documented to have a considerable amount of negatives to it. So the question is, why should we take those negatives without having proven positives? And second of all, how do the negatives compare to the positives? Well, these are some of the things that are still in dispute and being worked on, trying to be figured out. But unfortunately, a lot of the people promoting the climate change story here don't want to discuss it. They say this is a resolved matter, not even going to discuss it, blah, 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 blah. And that's counterproductive here. It's too bad that's what's happening, because we should be able to have objective, polite conversations about these type of matters here. Doesn't the contribution towards greenhouse gases by a volcano eruptions greatly eclipse anything from the burning of hydrocarbons. Well, there was an email that went around quite a while ago about a professor in Australia saying that, and they quoted him, but I happen to know this person and asked him, and he said, no, that's false. I never said that. We have I can send people a chart that I found really interesting that lists the top 10 sources of CO2. And you can see how much of those are. But volcanoes actually, I'm doing this by memory here, and I'm not saying your show. I don't think the volcanoes eclipses the man-made part. But some other things do. As an example, the amount of CO2 given off by insects does eclipse the amount of CO2 generated by man-made causes. Well, okay. Let's think about that. So what control do we have over insect populations and going up or down? And so how do we know that those aren't increasing or decreasing for a variety of reasons? But there's some other very interesting sources of CO2. And the other part of it is what's called CO2 sinks. That means certain things absorb CO2, and that's another part of the equation that we have very little understanding of. In fact, I saw a chart put up at the Woods Hole Institute in Massachusetts, which is pro climate change, and they indicated on their chart here that something like 30% of CO2 sinks that are unknown, that we don't have a handle on. We don't understand where they are, how they're fit in the picture. So there's a lot of variables here, and that's why I'm saying here that we can't say this is all scientifically resolved. There's way too many variables that are still going on here. How to explain rising seas and rapidly melting ice? Well, some of those things are in dispute. I live on the water, as an example, in North Carolina, and if you look at the tidal gauges, which are really, these are empirical things here, right there on the ground, measuring water, there has been by and large, a linear increase of water. But sea level I'm talking about. But the fact is, this linear increase has gone back well over 100 years. So there's been very little, if any, noticeable change from when fossil fuels, let's say, took off, let's say in 1950s as an example, from what they were in the 20s or 30s or 40s or 60s or 70s or 80s. So the change has not been consistent with an accelerated rate by and large. In fact, there's some parts of the world that are going down because there's other effects like subsidence that take into effect. But by and large, places that are not subsidence oriented are going up at a linear rate. So I haven't seen anything about accelerated rates. And as I say, I live on the water myself, on the ocean. And if this was the case here, it'd be coming into my yard. And I can tell you it isn't. So check it out. I can give you more information. I'm just giving you a quick answer here, of course. But let's see. Just termites emission exceeded mankind. Well, that's right. Well, I don't know if it's just termites, but insects in any case. Okay. Matt Peeler. Hi, Matt. Thank you for coming today. Matt used to be a county commissioner here in North Carolina. Yes, Neil Marner's papers here. He is a world expert on this, and he disputes these claims. So, okay, I think I've quickly touched on anybody else. Anybody else have a quick question? If not, then feel free to send me an email personally. I'd be glad to. Okay, let's see. Does the short residence time, Len, of individual CO2 tell us how long excess CO2 overall will remain? An individual molecule may fall into the sea, but this will last for centuries. Okay. Well, okay. All I'm reporting to you, Len, is what these peer-reviewed papers said here. So what you're effectively saying is that all these peer-reviewed people here are falling into a misunderstanding as well. So if in fact the IPCC has not properly defined things, well, then I'm just showing you what peer-reviewed papers are saying by comparison. So Effectively, you're saying none of these scientists got it either, because they're disputing the IPCC. And if you're saying the IPCC is saying something else, that means they're mistaken, every one of them, all these peer-reviewed papers. So fine, if you think that's your position, that's fine. But none of this is about measuring individual molecules. Obviously, no one can measure an individual molecule. It's a composite look. Okay, I guess we've covered all the things here, Paul. So I guess you can wrap things up.
Okay, thank you very much, John. We appreciate it. And thank you for joining us today. Thank you for watching the third of 5 lectures sponsored by Advocates for Balance at Chautauqua. Next week, August 13th at 4 p.m., our speaker will be Dr. Gary Wolfram of Hillsdale College, whose topic will be Healthcare in the U.S., Unintended Consequences of Government Intervention. Now, to register for this or the remaining lectures, please visit our website, abc@chq.com. And while there, think about joining our group and perhaps donating to our cause even. Just hit the donate button on our homepage. I'm Paul Anthony, and thank you again on behalf of Advocates for Balance at Chautauqua for your participation. You have a good day. We'll see you next week.